Welcome to Raychaudhri equation part 3. So in the last lecture we discussed Albert Einstein's field equations. We said the right hand side gives is dependent upon the mass, and on the left hand side this one is 0, the cosmological constant for most purposes, unless you are working on cosmology with distances of millions of light years. So this becomes 0, and R is the Ricci scalar and Riemann tensor or Ricci tensor. These two represent the curvature. So basic, and the G mu nu represent the metric or the measuring stick. So this side gives the mass and this side gives the curvature. More mass, more curvature. So if we know the curvature, we could get this side, the mass, or vice versa. And we said how we calculate the mass at the black hole, 4 million times the mass of our sun. Using these trajectories, we can tell what's the mass there, but we don't see anything there. So it's a black hole. So now we are going to talk about the geodesic equation, or the tracks that the planets move. Now on the left hand side, tau is the proper time. Let's call it just time for now. X is a dimension, it's a coordinate. So this gives us some kind of acceleration, and this gamma is called the Christoffel symbol, that a measure of curvature. This Christoffel symbol is a measure of the curvature of space-time. And again, x and tau. So these two are velocities, some type of velocities. So we need to find the acceleration of the planet or whatever that is moving. If we need to find that, we need to find this gamma, the Christoffel symbol. And to find Christoffel symbol, we have this equation, Christoffel symbol in terms of metric tensor, the measuring stick. So, but we just don't know the metric tensor. So we don't know the metric tensor to calculate this. So how to calculate the metric tensor? So we come back to Einstein's field equations. So we have to know the masses. So we find this side, this is 0, but again we don't know this. How to find that? So we have the Ricci tensor in terms of Christoffel symbol again, and we know the Christoffel symbol in terms of the metric tensor. So we put that in here. So we know Ricci tensor in terms of metric tensor. So we take that here and put it in here. So we have all values on this side in metric tensor and all values on this side on mass. So you need to know the mass, or we need to know this side or that side. So if you know the mass, then we could calculate the metric tensor. Now once you calculate the metric tensor, you put the metric tensor here. These are differentials of the metric tensor, and you can calculate the Christoffel symbol, gamma. And once you have the Christoffel symbol, then you can solve this equation, the geodesic equation. So once you have the geodesic equation, then we can do the trajectory. Now in the case of black holes, we didn't know the mass. So we did not know, let's go back here. In the case of black holes, we did not know the mass. Where's my Einstein's field equation? So we did not know this side, but we knew the trajectories and the velocities and the accelerations and all that. So we know these two, and the metric has to be guessed, and then we can calculate the mass. So again, this is the solving Einstein's field equations is extremely difficult. It's trial and error, very difficult procedure. A lot of computing is done, but I just gave you the overview. We just need some idea. So again, we have a geodesic. What is a geodesic? It's the tracks that planets move in a gravitational field, whether there's sun or something. Then how our Earth moves is given by this equation. So they don't move whatever the way they want. They move as per this equation. This is the geodesic equation, and this is important to understand for the Raychaudhri equation. Thank you very much for listening.